our goal is to prove T given three premises. We have the disjunction R or parentheses S and T. We have the conditional if U then not R, and the disjunction U or T. First, let's use our intuition to see if T follows from those premises. Okay, so let's say that R is the case. That's a disjunction. So either R is the case or S and T are the case, or both can be the case. If R is the case, this would contradict this consequent to a conditional, and therefore U would not be the case. But if U was not the case, in this disjunction, T would have to be the case. So T would be the case. On the other hand, let's say this R is not the case, then S and T would be the case. And once again, we get T as our conclusion. So we're good to go. This is definitely valid. So let's use our various rules of inference and logical equivalencies. So the first thing I think we should do here is at least eventually turn line 3 into a conditional. We can do that by implication, but before then, we better do some double negation. So line 4, we can get not U or T, double negation line 3. And then for line 5, we can do our implication, if not U, then T, implication line 4. And if you look really, really close, we could do a hypothetical syllogism. However, we would need to use contraposition on line 2. So for line 6, we can get if not R, then not U, contraposition line 2. Then we can do a double negation. So 7, we have R implies not U, double negation line 6. Here is our hypothetical syllogism, if R, then not U, but if not U, then T. Thus for line 8, we can get if R, then T, hypothetical syllogism, lines 5 and 7. Now this is going to be a little bit tricky. I did this problem before recording this video, so don't think I could just see this right away what to do next. But what we're going to do is to resort to the distributive rule and then the commutative rule to simplify, because we're going to be engaging in eventually another implication and then another hypothetical syllogism. And sooner or later we will get a tautology to get T. So if you run into some dead ends, that's okay. Just stop and then backtrack and try again. So we will do the distribution rule or law on line 1 to get an equivalency. Hence for line 9, we have parentheses R or S, close parentheses, and parentheses R or T, close parentheses. Distribution, line 1. We're going to want this R or T, and because some textbooks are very, very fussy, I'm just going to use the commutative rule. So we'll get R or T, then and the R or S, commutative rule, line 9, and then we'll simplify. So R or T, simplification, 10. I'm going to want a if not T then R. So one of the things we'll have to do is do the commutative rule. So for 12, because we want the R and T flipped, so T or R, commutative rule, 11. And then for the implication, we'll have to do a double negation. So 13, not T or R. And then for 14, we can get if not T, then R, by implication, line 13. So look very, very closely. We have this if not T, then R, and then if this R, then this T. Hence for line 15, we have if not T, then T. Hypothetical syllogism, lines 14 and 8. But let's do another implication. let's get back to a disjunction, because we're going to want a tautology, right? So for 16, we can get not t or t by the implication of line 15. And then for 17, we have that double negation there, so we have t or t, double negation, line 16. Well, t or t, that's just t, so for 18, it therefore follows t because we have a tautology, line 17. And that is our final answer. It was tricky, took some time, and you have to think ahead on these types of tricky proofs, but they are fun and they do develop your skills in logic. But if you run into a dead end, just try again. Keep on trying and you'll get it.